Alright guys, so here are those notes that I posted a picture of. A lot of you came up with a lot of good things about a parabola, so we can be U-shaped, either pointing up, pointing down. This is generally what the equation looks like. It's got a vertex and axis of symmetry. Now, some of the new things that I talked about in the previous video is that it has a focus, a directrix. A focus is a point kind of inside the parabola. A directrix is a line sort of under the parabola or on the opposite side of the parabola. And you can get really 4 different things here. You can get a pointing up parabola, focus inside, directrix under, pointing down parabola, focus inside, directrix kind of over. Or now we can talk about non-functional parabolas that point to the right or point to the left, and we still have our focus kind of inside, directrix outside. And the unique thing about the focus and directrix is that they are always equidistant from your parabola. Now, I don't know if we noticed or not, but there was like a 1/4 sort of deal, or always like a fractional thing going on with our focus and directrix. If you looked at that card sort, maybe you noticed that. So I'm going to pause on the circle thing. We'll come back to that, and I'm going to fill out some notes about our parabola. Okay, so at the top, we have our 2 equations. Again, in that card sort that I had you guys try, hopefully you noticed that parabola equations are unique because they have one letter by themselves, where all the others like x and y were on the same side. Y is by itself or x is by itself on one side. Also, a good thing to notice that a lot of you pointed out is that only one variable is squared. They're not both squared, which all of the other ones, both x and y, were both squared. Now for our y equals parabola, that is what we are used to. In vertex form, we are h comma k. If a is bigger than 0, we open up because we're positive. If a is less than 0, we point down because we're negative. So really this is just talking about positive, that's just talking about negative. And then your focus point, which again, if you were taking a look at those cards closely, and I know there were like a bajillion of them, maybe you noticed that the x value of the focus was the same as the vertex, but the k value is always adjusted, and it's adjusted by however long that distance is between your focus and parabola. And you can find that distance by using a little formula, 1/4a, whatever your a value is. So I don't know if you noticed that there was like a 1/4 thing going on or something to do with a going on there, but if you did, that's awesome. So to find that focal length, we have a little formula for that. And it is that 1/4a thing. We call our focal length always the letter c. So sometimes you'll see this written as k plus c, but c is really just 1/4a. So either way you think about it. And it could actually be subtracted depending on if we're going up or down. Now the directrix is a line, and because this is a pointing up or pointing down parabola, your directrix will always be a horizontal line, so a y equal line. And here we adjusted the y value because the focus will move up or down. And so the horizontal line will also have to do with your k value, but instead of going up that amount, it'll go down that amount, or vice versa, if your parabola is pointing in the other direction. Okay, so all that stuff is true for an x equal parabola, although these parabolas will open right if we are positive, or left if we're negative. So same equation, except x and y are swapped. Your vertex is still h comma k, because whatever is with y is the y value, so like k is still here, so it's still your y value. Now h is outside, so they're kind of in a different order, but the one with y is the y value, so hopefully that kind of helps. Your focus still a point, but this time, so your focus is always going to move away from your vertex, and because our parabola is pointing right or left, it's going to move it left or right, depending on which way you go. So your x value of your vertex will be adjusted, so h plus 1/4a, that focal length, and k is not going to change at all because we're just moving left or right. And your directrix is that line, and this time, because we are pointing left or right, your line will be going up or down, And so our equation will always be an x equal equation, and it's that h value or x value of your vertex being adjusted again by the same amount, just in the opposite direction. So that 1 over 4a, but instead of adding it, we subtract it. Okay, so if we maybe try two quick ones, a really easy one would be y equals 3x squared. So we can find our vertex. There's nothing inside, nothing outside, so it's 0, 0. Because we're positive and it's a y equals, I know that I'm a parabola pointing up. We can find our focus by getting that focal length. So because I'm an up parabola, I know the x value of my focus will stay the same as the vertex. It won't move left or right at all, it's just going to move up or down. And in this case, it's going to move up. So it's going to be 0 plus whatever that 1 over 4a is. And I have a, it's 3. So 1 over 4 times 3, so 1/12. And because the vertex is at 0, 0 plus 1/12 is just 1/12. So that's where your focus is going to be. Your directrix will just go in the opposite direction of that. And again, it's going to be y equals horizontal line. So it's not going to be up a 12th. It's going to go down a 12th. So negative 1/12, which is real teeny tiny. And so like if we sketch this out, we got our vertex at 0, 0. We can kind of use our 3 as our slope because that's like still a thing that we know about. And so we get our parabola here. Now 1/12 is real teeny tiny, so your focus is just a little bit up from that. And then your directrix is that horizontal line down here just a little bit below it at negative 1/12. So hopefully some of the guesses that you made through that Desmos activity are like verified here. Now let's try one that's much different. So hopefully that, was a little familiar, but let's try an x equals. So we got x equals half, parenthesis, y plus 2 squared. Okay, so we still want to find the same three pieces of information. So our vertex is at x comma y. Now the y value is with y, so it's negative 2. And then there's nothing outside, so 0. So 0 comma negative 2 is where my vertex is. Now because this is positive and it's an x, it's pointing in the positive x direction, which is to the right. So like I can kind of imagine my parabola looking like this. Okay, so focus. Now because I'm an x parabola, the x value of my vertex will change, meaning the y value will stay the same for the focus. And it's going to either increase or decrease by that 1/4 a amount. So a this time is half, and half of 4 is 2, so half. And so I'm just going to either add or subtract that to the 0. Now I can see that I need to add it because I need to go to the right because this parabola is pointing to the right. So 0 plus half will get me my focus at half comma negative 2. And then your directrix just goes in the opposite direction. So 0 minus half gives us our directrix at x equals negative half. Okay, so we can plot this guy. We got our focus, or our vertex rather, which is at 0 comma negative 2. We don't really, you can think about the slope being half, so it's a little bit wider parabola. And then we can plot our focus, which is at half comma negative 2, so it just moved a little bit in. And then our directrix is that vertical line at negative half. Okay, so I'm going to have you guys maybe try 2 on the inside here. I'll give you one x1 and one y1 to try out. We'll see how that goes. So x equals, we'll go 1/4 parenthesis y minus 2 squared minus 3. And then we'll try a y equals 1, so we'll do y equals 2 parenthesis x minus 1 squared plus 2. Okay, so we'll try those two parabolas. kind of as your assignment for this week or this weekend. And let's go back and talk about circles real quick. So you guys gave me a lot of good circle things that you remembered. A circle has a center that is equidistant from kind of the outside edge. The equation right here, which I can't remember if I said in that video or not, is really just like the Pythagorean theorem on steroids a little bit, or like your distance formula. And that's because the way a circle is kind of made, we get this right triangle in here, which basically just uses the Pythagorean theorem to get all these points going around, and my circle got a little goofed. It looks more like a potato than anything. Blaine wanted me to remind you that there are arcs going on in here, so that was a fun fact, and they're fun and cute, like I said last time. So the circles are pretty basic, and I don't know if you would have learned how to graph them last year in geometry or not, but they're super duper easy, so we'll jump to circles. In that Desmos activity, maybe the way that you noticed a circle was a circle rather than anything else like ellipse or hyperbola is that it didn't have any division bars, and also both the variables were squared unlike a parabola, so there's kind of that way to tell that a circle is a circle. Now if it's very basic like this one here, your center is just at 0, 0. Your radius is r, so note that to get from here to here we gotta square root it if we want the radius. Similarly here, the center now is a little bit changed, so h comma k is your center, just opposites of the inside, and your radius is still r, and we're still going to want to square root it unless they tell me the radius and I want to get it into the equation, then we want to square it. So just depending on which way you're going, you're going to do different things. Now a circle doesn't really have a focus or a directrix or anything like that, because we talked about when I was doing that folding that the focus is really just on the edge of the circle, and so it doesn't really exist anymore as a point. It's just kind of gone. Okay, so some graphs to try together. If we have something like x squared plus y squared equals 16, I can tell that the center is at 0, 0 because there's nothing inside parentheses, and the radius would be 4 because the square root of 16 is 4. So the way that I graph a circle is super easy. I plot my center, and then I go out from that center 4 in every direction that's easy. So it's easy to just go up 4, or over 4, or down 4, or left 4. It's not really easy to go diagonal 4, so I just don't. And then I just want to make it look as circular as you can and less like a potato, because mine is definitely a potato. So one where it's maybe a little bit trickier, I don't know, circles are never really that tricky. If we have x minus 1 squared plus y plus 3 squared equals 1, I identify my center. It's just the opposites inside, like x is with x, y is with y, so 1 comma negative 3. And then my radius, I just square root that boy. Square root of 1 is still 1. So I plot my center, which is at 1 comma negative 3. I go out 1 in every direction. That's easy. And when it's smaller, it's definitely easier to be circular. But because I'm me, I still get a potato. So, you know, we try. Alright, I'm going to give you 2 of those to try as well, just for funsies, because like circles are so easy and fun. Why not? We'll do x plus 2 squared plus y squared equals 4, and then we'll try x plus 3 squared plus y minus 2 squared equals 9. And try those out, snap a pic, send me a pic, super fun. That's it for today.